is May 19, paper 1, question 5. A camera at point C is 3 meters from the edge of a straight line, okay? The camera detects the car traveling along the road, so going this way, at t equals 0. It then rotates, always pointing at the car. Sure, it's following the car, which is going this way, until the car passes 0. The point on the edge of the road, closest to the camera. Cool. So that means that this right here is a 90-degree angle. All right, so now, a car travels along the road at a speed of 24. So, dx dt equals 24 meters per second. The position of the car will be x. Let OCX, right here equal theta, sounds good. D theta dt, we want to find that. Okay. Well, if we want to find d theta dt, we're going to have to find some sort of ratio. Now, what do we have? If we have this one, we know that the sine of this angle right here will equal the opposite of the hypotenuse, so that's not going to work. But the tangent of the angle right here will equal the opposite of the adjacent. Okay, so let's try that. Tangent of theta equals OX over 3. If I derive this with respect to t, d dt, tangent of theta is equal to 1/3 d dt OX. And we were calling this right here the distance of x with respect to time. That's already dx dt. So this is equal to 1/3 times 24, and this is secant squared of theta equals 8 meters per second. Now we want this, that's in general. Wait, so it's always that? That's surprising. So x squared, y squared, that's 3, just to try. I know that y squared equals x squared plus 3 squared. If I take the derivative of everything with respect to what? With respect to t? 2y dy dx equals 2x dx. Sorry, dy dt. X dt plus 0, okay? So we have dx dt equals y over x dy dx. I'm not sure that's helping me a whole lot, because this is not a constant, so that's not very helpful.
Age is a constant.
No. As this car moves forwards, right, this line is going to get shorter and shorter and shorter.
Okay.
Really, the secant of theta is going to get smaller and smaller and smaller. So maybe we're just okay here. Secant squared of theta is equal to 8. I see where my problem is, because I'm not finding d theta. Okay, so that was not correct, because I didn't derive it properly. Because this would be correct if I was deriving with respect to theta, but I'm not. I'm deriving with respect to t. This was derived with respect to t. This should be secant squared of theta, d theta dt equals 8. So d theta dt equals 8 divided by secant squared of theta, which is 8 cosine squared of theta. Now, I need to find the cosine squared of theta at this point. And the cosine of this angle, right there, well, this angle is going to be 0, right? When this line approaches,
Yes.
theta is going to become 0. And the cosine of 0, what's the cosine of 0?
1.
It's 1. This will be 1. So this will be 8. So the rate of rotation of the camera will be 8 radians per second at the instant the car passes the point O.
Okay.
I think that makes sense. So here, really, I got sloppy because I rushed through it, because I forgot, really, that this has to be. that I needed to put d theta dt there. It doesn't make any sense. I'm not deriving with respect to theta, I'm deriving with respect to t. This right here makes sense. We've already got this distance. This x dx dt is consistently 24 because right here, it's always 24, kind of regardless of where its position is. So that's fine. So the size of OX is irrelevant because the differential there is always 24. So therefore, once I remembered my d theta dt, it's still equal to 8. This is 1 over cosine, so that becomes cosine. And at the moment it passes, the cosine is 0. The angle is 0.
The angle is 0.
And
so
so
it's probably 8
it's,
to 8.
so it's 8 meters per second. I think that's it.